Hi, today we are going to look at quite a few properties. The beginning of them go with the properties of algebra, but we are going to be introduced and work with some geometric properties. So the first section here down to substitution, actually I'm going to go like this, down to division. These are properties of equality. So you have what's called an addition property of equality, a subtraction property, multiplication and division property of equality. These four properties are what you do when you solve equations. Okay, so let's go through the first four and you'll kind of get the idea of the if-then statements we're going to write. So we're going to have examples where A, B, and C are real numbers. So if you have A equals B, let's say you have one quantity equal to another, then the addition property of equality says I can introduce C. So if I do A plus C, it is equal to B plus C. Okay, so an example of this would be like if 4x minus 3 equals 1, so if A equals B, to solve this, I would add 3 to both sides. So that in essence is like my C. So then I would have 4x equals 4 and so forth. So by adding the same item to both sides, you have performed the addition property of equality. So subtraction, multiplication, and division are going to follow. So the subtraction property of equality, if A equals B, then A minus C is equal to B minus C. If you subtract the same thing from both sides, you've kept that equation in balance. Multiplication property of equality, if A equals B, then if I multiply both sides by C, then A times C equals B times C. Okay, and finally the division property of equality. If A equals B and we don't let C equal 0, then A divided by C is equal to B divided by C. So of course I can't have that B equal to 0, otherwise we cannot divide. So when you do the same thing to both sides, you have kept the equation in balance or equal. So these are all properties of equality. Okay, so we did these a little in Algebra 1 last year. Now, your substitution property is not necessarily a property of equality because you don't have to substitute on both sides of the equation. So the substitution property, if A equals B, then, I'm going to put here in quotes, then A can be substituted for B into any equation. Okay. Or expression. So if you have two items that are equal, you can plug one in place of the other. Okay, or you could plug B in place of A. The order doesn't matter. So you're not necessarily applying that on both sides, so we typically would not refer to that as a property of equality because it doesn't keep that equation in balance. And then your distributive property that you're familiar with, if A and then you have times B plus C, if that's true, then we distribute into our parentheses, so A times B plus A times C is the result. Okay, so we will use these properties quite a bit. All right, now the next few are going to be new. So I want you to just kind of see the organization here. We have reflexive properties of equality, we have symmetric properties of equality, and then transitive properties of equality. So we really just have three. We have the reflexive property of equality, we have a symmetric property of equality, and a transitive. What you see under here are just three types of examples. These three examples are the same property, okay? It's just being viewed in different ways. So I don't want you to think we've got 3, 6, 9 properties. We just have 1, 2, 3, all right? So our first one is called the reflexive property of equality. So these are going to take some getting used to. We will use these quite a bit, but at first it's just going to take some getting used to. So the reflexive property of equality sometimes is hard to wrap your mind around because it's so incredibly basic that it feels like it's unnecessary. So let me show you what I mean. For any real number A is equal to A. A is equal to itself. Let's say I'm referring to segment lengths. For any segment AB, AB is equal to AB. The reflexive property just says an item is equal to itself. So maybe we're dealing with angle measures. For any angle A, the measure of angle A is equal to the measure of angle A. So an item equals itself. That is the reflexive property. And we come back to this one quite a bit in a couple units. But for right now, we're just getting used to what it's called and being able to identify it. So again, an item equaling itself. So these are just three various types of examples, but they're all just the reflexive property. So you don't need to distinguish real numbers from segment length from angle measure. I just want you to be able to see these and say, oh, that's the reflexive property of equality. Okay, second one, symmetric property of equality. All right, so again, there's just three examples just to give you an idea of how it works. For any real numbers A and B, if A equals B, then B is equal to A. So symmetric lets us switch them. Okay, so a good example of this is when you solve, let's say you solve the equation 5 equals x minus 1, and we come in and add 1 to both sides, and we get 6 equals x. Well, the symmetric property of equality allows me to switch it around. Okay, so we kind of naturally do that. I know I tend to do that a lot, but that's because of the symmetric. So a segment length example would read, for any segments A, B, and CD, if the length of AB is equal to the length of CD, then CD equals AB. Okay, again, they switch. And then an angle measure example. For any angles A and B, if the measure of angle A equals the measure of angle B, then I can switch them. Then the measure of angle B equals the measure of angle A. So I always think symmetric switches, symmetric switching, the switching property, okay? Reflexive is just itself, symmetric switches. Lastly is transitive property of equality. Okay, transitive property of equality. All right, so the transitive property of equality says, for any real numbers A, B, and C, so notice one difference here, I have 3 quantities and I only have 2 here. For any real numbers A, B, and C, if A is equal to B and B is equal to, oh, not A, sorry, and B is equal to C, so let me start that over. If A equals B and B equals C, then A is going to equal C. So if A equals B and B equals C, then A equals C. So that should sound a little familiar from earlier in the unit. That's like the law of syllogism. Transitive property is really the law of syllogism. I like to think that the transitive property like transfers the equality from the beginning to the end, okay? So let's go through these last two. For any segments A, B, C, D, and E, F, if the length of AB is equal to the length of CD, and the length of CD is equal to the length of EF, then the length of AB equals EF. So it's like saying if 1 equals 2 and 2 equals 3, well then doesn't 1 go straight to 3? Okay, so it's like transfers the equality. So here would be an angle measure example. For any angles A, B, and C. Oop, I have 2 ifs there. Guess I can get rid of one. If the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then measure of A equals B. Then the measure of angle A, I'm sorry, equals the measure of angle C. I said that wrong. Okay, let's start over. If the measure of angle A equals measure of angle B and B equals C, then A equals C. I forgot my angle sign in there, so I'm trying to squeeze that in. Okay, so we've got, of these last 3, I want you to kind of notice some things as you're studying these. The reflexive property, see how it's just one thing. One item equals itself. One item. Symmetric property, I have 2. A and B, these 2 segments, these 2 angles. So the symmetric property, I only have 2 items and they switch. Transitive, I have 3. I have A, B, and C. I've got angles A, B, and C. And so the transitive property transfers the equality. Okay, so as you are trying to remember these, go through exercises over these, I want you to think about that idea. All right, so we've got the algebraic ones should hopefully be pretty straightforward to you because whatever you're doing in your math is the name of the property, and then these three are going to be the new ones for you. Okay, well, I'm going to stop this video here because then we've got some examples. All right, so let me go to the next video when you're ready and we can work through examples.